Today we talk about Java streams, the feature that makes Java feel modern. Java streams in 5 minutes, maybe. Anyway, we will talk about what a stream is, why industry uses it, common operations, lambdas and method references, pitfalls, and best practices. Let's get going. What is a stream? A stream, it's a pipeline for processing sequences of data. And it takes a declarative approach. So we're more concerned about what it does than how it does it. And no storage. So it operates as a source. So a list, a set, some kind of collection. And lazy execution. So the work only happens at the terminal operation. So the way you can think about a stream is you can think about it as you have a collection of items, okay, and you put the items on the conveyor belt, okay, and on this conveyor belt you perform all sorts of operations on these items, and at the end you get a result. So that's how you think about streams. So on the conveyor belt you have these intermediate operations. So the box of items is the source. The conveyor belt has the intermediate operations performing various operations on the items on the conveyor belt. And then you have the finished product from the terminal operation. Anyway, let's keep going. Why does industry use streams? So for readable transformations, so when you read the code, you can kind of tell what's going on. Fewer loops and changeable state, easier parallelization, so it's easier to run things in parallel. And it's pretty common to use streams in Spring data and data processing. So here's a stream pipeline. So as I already alluded to, the basic syntax of the stream is you have a source, which is usually some kind of collection, intermediate operations, and these intermediate operations return another stream. And then you have the terminal operation, which lazily executes the stream. So for an example, you have a list.stream, .filter, .map, .collect. So again, you have your collection, you have all these intermediate operations being performed, and then you get a new collection. But the thing is, the original collection remains intact. So here's some common intermediate operations. We have filter, which takes in a predicate, map, which takes in a function. We have sorted, distinct, limit, skip. We have peek. And you'll see some of these when we do the demo. Common terminal operations. So these are our lazily executed operations. We have a for each, which I'm sure you've seen many times. Collect, count, reduce, any match, all match, none match, find first, find any. And find first and find any, they return an option. We use lambdas in streams a lot. As a matter of fact, lambdas are one of the things that make streams possible. They provide behavior in line. So you can pass this behavior as a parameter or as an argument rather. Okay. And again, filter uses a predicate. Map uses a function. For each uses a consumer. Method references are shorthand for simple lambdas. So method references can be class followed by the static method, an object followed by its instance method, or class followed by the new keyword. Examples include this string to uppercase with the two colons in between, and system.out print line with the two colons in between. This will make sense when you see it live in a demo. Then you have collectors and grouping. So you have the collect, you have join in, group and by, which is very similar to what you would see in SQL, mapping, counting. And we have parallel streams. So parallel streams allows us to execute multiple streams in parallel. So essentially it allows multi-threading. It allows different threads. So it avoids mutable state, but it's not ideal for input-output or small collections. So the best practices is that we prefer readability over cleverness. We want to avoid side effects. We use optionals with find first, find any. So find first, find any will return an optional. And benchmark before parallelizing. All right, welcome back to Eclipse. So here's our streams demo. So as you can see here, this is how Java was traditionally written, with loops, mutable lists, and manual filtering. It works, but it's verbose and it's easy to make mistakes. So here, the goal is to filter out names that are shorter than 4 characters. So we only want to keep names that are longer than 4 characters. We want to convert them all to uppercase and we want to print. So what we're going to do here is we're going to take these loops and replace them with streams. So let's go. So as you can see, we have taken those loops and we have converted them to streams. And a stream that allows us to describe what we want instead of how to do it. So as you can see, we have a source called names. We're taking these names, converting it to a stream. And then we will filter out for names that are greater than 4 letters in length. Then we will uppercase these names, and then we will print each of these names. So let's go ahead and run this and see what we get. So we have 4 uppercase names greater than 4 letters in length. Okay, so what are we going to do next? I guess we're supposed to illustrate the laziness of this operation. So let's remove this terminal operation, which is the for each. We'll save it. Let's run it. And what do we get? We get nothing. Okay. So basically it means streams don't execute until a terminal operation happens. This is called lazy execution or lazy evaluation. So let's undo these changes. Okay. But instead of this, let's use a method reference instead. So system.out print line. Now let's execute this again. Same thing. So here we use the method reference. And this method reference is extremely common in enterprise production code. Now let's store the result. So we'll store this in a variable. So what we did is we collected this to a list. So streams don't have to just print. They can produce a new collection, which is exactly what we did here. So let's go ahead and run this. And it prints our array list. Now let's move on to numeric streams. So we can remove this code now. Okay. So here we have a numeric stream. So we're taking the list of numbers, we're using it as a source, converting it to a stream, and we're using this reduce method to produce a singular result. So we're taking this list and combining it into one result. So we're using this to sum up some numbers and produce a sum. So let's make sure we save this. We'll run it. All right. So we have a sum, but we can do a little better. We can do much better. So let's take this and we'll map to int. Then we'll sum it up. Let's save it. Print. All right. We still get a sum of 26, except this makes a little more sense. All right. Now we're going to go ahead and use optionals. All right, so what we're going to do is we're going to find the first name that starts with Z. So we're going to create an optional. All right, so what we've done is we've taken these names as a source, streamed it, filtered out names starting with Z, rather filtered for names starting with Z, and we're going to find the first value. Now find first, it returns an optional. The reason it returns an optional is there's a possibility that that value may not exist. Okay, so we take the first and invoke the if present method, print out the method using this method reference. So I'll make sure I save it and let's print it. And you know what? The reason this is not printing is because we don't have anybody with a name that starts with Z. So let's find somebody. Let's add one. All right, let's run it now. Now we have Zach. So you see, it actually worked. We didn't have a name there, so it didn't do anything. I put a name in that starts with Z, and it did something. Would you look at that? Okay, now we'll do another example. All right, now we're going to do some grouping. So essentially, we're going to group names by length. So let's begin. All right, so we've grouped these names by length. So we're taking in the names again as a source, streaming it, then we're collecting it using the collector's grouping by. So we're grouping by the length of the names. So let's run this and see what we get. All right. So these are the names with 3 letters, with 4 letters, so on and so forth. All right, the last topic we're going to cover is parallel streams. We're just going to cover this briefly. Parallel streams is one of those methods that you should not blindly use. This is mainly used to run more than one stream at a time. But we'll just use a simple example. So we have a list of numbers from 1 to 10,000. And what I want to do is I want to square these numbers. So I'm going to use numbers as a source. All right. So we're going to use this parallel stream. Let's see what it does. Because honestly, this is the first time I'm using this method. So let's see. Okay, it worked pretty quickly. All right. It looks like we're done. And I'm just going to close by saying that streams aren't about writing less code. They're about writing safer, more readable code. Once you understand streams, you start writing Java the way modern backend systems actually expect. Thank you. And as I say at the end, I'm out. And this will be the last video in my Java tutorial series. But that doesn't mean I will stop putting out content. So look out for the next one.